let's talk about characters in general. Now, if I have a letter such as A, how does that letter get represented on the computer? Anybody know? Okay, wait, I'm looking at the wrong name. Donald? Okay, converted to ASCII. How many people have heard of ASCII? How many people have heard of ASCII? Okay, so ASCII stands, well, what is ASCII? What is ASCII? It's what? It's a standard code. Okay, so here is not the most beautiful ASCII table in the world, but let's take a look at this. Okay, so what I've got is on the far right, look at the red letters. Look at the red characters. So if I take a look at lowercase a, which is the example that I started with, if I take a look at lowercase a, notice that lowercase a is decimal 97. Okay, that's great, but what's the problem with converting decimal to binary? Wasn't that kind of annoying? Yeah. So if I take a look at ASCII A and see that it's a hex 61, oh, wait, I might be able to actually do that. So 61, how do I convert that to binary? I start at the right-hand side. The 1 is 4 digits, and the 6 is, so there's the binary for ASCII A. We don't have to know these by heart, okay? I just want everybody to understand that there's a unique binary code for every single printable letter. So let's look. So we have A through Z. Now notice that capital A is different. It's a 41 hex. Why is capital A different than lowercase a? Jerry? Yeah, because if I type a letter and I want to store lowercase, I want that to be there. I don't want to just generically put an uppercase there, right? So the uppercase and lowercase are distinctly different. Let's look what else we have in the red. We have characters. We have numbers such as 0 through 9. We have punctuation. We have all kinds of characters. And then we have this weird data set which typically varies from PC. The lower, how many is it? The lower 30 are typically vary per PC. Okay? So these are all ASCII characters. Now, how much space does each one of these characters take up, do you think? A byte each. A character takes up 1 byte. Character takes up 1 byte, 8 bits. Okay. So we're looking at ASCII. That is not the only game in town. It's typically used on PCs. There is another code that's also well known. It's the extended binary coded decimal interchange code. That has a different set of values. So if by some chance you're interfacing with a device that's not using the same codes for your numerics and your letters, then you have to make sure that you account for that. Okay? So the first data type we're going to look at is a string. And a string is a what? Set of characters. So give me some examples of where a string might be used. Where might a string be used in a program? A name. Last name, first name. We used it yesterday in our programs in lab. Last name, first name. What else? What's that? Okay, or even 1 month. Okay. State, William, Adam? To enter horse's name for races, to enter company names, city names. They're used a lot. Okay? Now remember also, don't forget that things like social security numbers, zip code, and phone numbers should also use type string. Does that make sense? Okay. All right. So when you declare a string, we have to use string and whatever the variable is. Now, yesterday in lab, we also had to do something else. Do you remember what that was? Do we have to include something specific? Didn't we have to pound include string? I believe we did, because in C, string is not a given data type, so you have to pound include string every time you want to use string. Okay? So up at the top, it's pound include string, and then you can use the string data type. Now, notice that if I declare a string, space is allocated in memory, and if I want to assign a string, what do I have to use? Why did I have to use quotes? What would happen if I did not use quotes? Wouldn't work, but why? What would it think? What would it think John was? Thinks it's another variable, and it would say undeclared identifier. So by putting quotes around it, that says this becomes a string of characters. Assign that string of characters to the variable called name. And we know how this would be stored because we'd find the ASCII value for J here, whatever that is. I could look it up. It's not a mystery. This would be the ASCII value for O. This would be the ASCII value for H, and this would be the ASCII value for N. So how many bits would that take up? No. No. How many bits would that take up? How many bits does a character take up? Well, 7, but it's really 8 because you can't go on an uneven value. So every character takes up 8 bits. So let's repeat the question. How many bits does this string take up? 32. 8 times 4. Each character comprises 8 bits. Each character comprises 8 bits. Okay, so do I not do the character type here? Okay, so the other type, which I don't have a slide for, is the character data type. And give me an example of where we might use char. Where might we use the char data type? Tyler? A single character. Okay, so we use it for sex, male or female. Adam? Letter grades. Other examples? Middle initial. Code entered for a menu, A, B, C, D. Okay, so let's say that you call this letter. So let's say that so how much space is allocated for letter? How much space is allocated for letter? 8 bits, thank you. 1 byte for a character, okay? So if I say letter equals A, we know exactly what goes in there, don't we? The 61. So it's pretty easy to see integer and characters, what exactly in memory. The others, we have to kind of take it on faith. So do you see the difference between a character and a string representation? What's the difference between a character representation and a string representation? Kevin? Is that your name? Okay, go ahead. That's correct. And how do I indicate what? Somebody can point right to it. This indicates what? Single quote indicates character. Double quote indicates string. You got that? Okay. Now we have one other data type that we didn't get to look at yesterday in lab too much. That's the Boolean. And in C, that is represented by bool. This is for a true-false value. Everybody's heard of Boolean. Can you give me examples where a program where I might use the Boolean data type? Can you give me examples, Tyler? Okay, so you could have a loop condition, done, or something like that. But what about a real-life problem? Brianna? Yes or no question, true or false question, yes. Anybody else? Go ahead. If it's a what? Okay, so we could have an, yeah, we could have it some type of state on or off. You guys are getting kind of I was kind of looking for something like really down and dirty. Yeah? Yeah, like eligible, bill paid. I mean, there's certain times where we create a problem and we want to know, did this person pay their bill? True or false? Is this person eligible for a scholarship? True or false? You know, things like that. These might be a good place to put a Boolean variable.